Hey guys, so here's part 2 of the 6.4 notes. We're going to talk about how to find the inverse of a linear equation, how to verify inverse functions, as well as do a word problem. Okay, so for example 3, we're going to find the inverse of the equation. We have y equals 5x plus 4. So the very first step when we are finding the inverse is to switch the x and y. So I'm going to have x equals 5y plus 4. Okay, now our second step is to solve for y. So my first step is to subtract 4 from both sides. So I get x minus 4 equals 5y. And then my last step is to divide both sides by 5. So I get y equals x minus 4 divided by 5. The last step that we have is going to be writing in inverse notation. Okay, so what is inverse notation? Well, here, what we're going to use is f of x. Now, it's going to look a little bit different. We're going to have this -1, and it looks like an exponent, like f to the negative first. But what this actually negative first really represents is meaning inverse. So it's not really an exponent. It's not saying we're taking something to the negative first power. No, it represents inverse. Now, you guys actually have seen a little bit of this notation when you guys did geometry and learned about the inverse of sine, cosine, and tangent. So you had arc sine, arc cosine, and arc tangent. And there they use that negative first to represent the inverse. Okay, so make sure you always do like f and then what we call inverse of x. So it's going to be that -1. It just represents inverse. Okay, so now we have that. Now we just write our final answer of that x minus 4 over 5. And then this is going to be our final answer for the inverse. Okay, now let's go ahead. Let's talk about how do we verify that two functions or equations or relations are inverses of each other. Okay, so the functions f and g are inverses of each other provided. So notice here we have f of g of x equals x and g of f of x equals x. So what this means is that we are going to create two composition of functions. And when you simplify and both composition of functions equal x, that means the functions are inverses. Okay, you might also find, you might see like g of x might also be denoted by f of negative first, so read as f in first. So you might just see some different stuff. So in order to verify, we need to create two compositions of functions. Once we have done that, both need to equal x. Okay, so if they don't equal x, then they are not inverses. Okay? Okay, so let's go ahead, let's do that for these problems. So our first one we're going to do is we're going to do f of g of x. So we have already practiced doing composition of functions. So this should be a nice review. So g of x is our inside function. So we're going to take the 1/3 x plus 5/3, and wherever we see x in our f of x function, we're going to replace it. So I have 3 times 1/3 x plus 5/3. Now don't forget on our f of x function, we have the -5 at the end. A lot of times students kind of forget that other part, but make sure you have that. Okay, now we're going to simplify. So I'm going to distribute my 3 to the 1/3 and the 5/3. So I get x plus, I get x plus 5 minus 5. Now what happens to the 5s? They do cancel out. So I'm left with x. Okay, so our first composition of function is equal to x. Now let's see about the second composition of functions. So that's going to be our g of f of x. So you got to show both of them. If you only show one, it doesn't work, okay? So now we're going to do the reverse. So we are now going to take our f of x function, which is now the inside, so our 3x minus 5, and for every place I see x, plug it or replace the x. So now I have 1/3 times 3x minus 5 plus 5/3. Okay, distribute my 1/3 to the 3x and negative 5. So I get x minus 5/3 plus 5/3. What do you notice with our 5/3? They do cancel out. So now I'm left with x. So now that I get both of them, I have shown that f of x and g of x are inverses. Okay, now for your homework assignment, it is going to ask you to verify, but also to say, are the two functions inverses? So you just have to make sure when you do the both composition of functions that both of them equal to x. Okay? Okay, now let's go ahead and do our last problem for this part. We're now going to do a word problem. This is going to be similar to what we have done before. So example 5 says elastic bands can be used in exercising to provide a range of resistance. A band's resistance R, which is in pounds, can be modeled by R equals 3/8 L minus 5, where L is the total length of the stretch band in inches. Now our first part is we're going to find the inverse model. Now when we have a real world problem and we're finding the inverse model, what we're going to do is we're not going to switch the variables. Okay, so do not switch variables like we did when we just did the linear equation. Instead, you're just going to solve for the other variable. So I would write this down so you remember. So anytime you have word problems and you're finding the inverse model, you don't want to switch the variables. Instead, solve for the other variable. So in this case, we have, for our model, R equals 3/8 L minus 5. So what we're going to do here is actually solve for L. Okay, to do that, the first thing is I'm going to add 5 to both sides. Now to get rid of this 3/8, I need to multiply both sides by the opposite. So that's going to be 8/3. Now I'm going to take my 8/3 and I'm going to multiply by the R and the 5. So I get 8/3 R plus 40/3 equals L. So this is going to be my inverse model. Okay. Now the second part says use your inverse function to find the length at which the band provides 19 pounds of resistance. So where are we going to plug that 19 pounds? Well, that's going to be plugged into R. So I'm going to have my 8/3. So I have my 8/3 times 19 plus 40 over 3 equals L. And we can use our calculator to do this if we need to. So let's do 8/3. So we have 19 times 8/3. And that gives us 152 over 3 plus 40/3. And we plug those into our calculator, and we get 64. Now, we need to make sure, because it does talk about the units, what is the L going to represent? Well, that's going to be in inches, so we're going to have 64 inches. There's our final answer there. Okay, make sure you guys watch the last part of the 6.4 notes. That's where we're going to talk about inverses, but of nonlinear functions.